Well, in this tutorial, we're going to talk about RC circuits and how to put them together. Let's get started. So, what you have right here is a few basic components of how to make an RC circuit. I'm going to talk about each of them. There's also a few other components that aren't here that you can have in your circuit, but we're not going to discuss in depth in this video. So let's get to the first one and the primarily important one, the battery. Its voltage and its current that it enables and allows is what's going to be what uh, it's going to be what powers your circuit and what limits everything else in your circuit. All right. Next up, what pretty much all the batteries are going to be connected to is your ESC, which is pretty much what powers your motors. Or what I should say is what drives your motors to act more, I guess, intelligently or based off of the receiver, what the receiver is getting from the transmitter or your controller. So both of these are ESCs or motor drivers, but the difference between these two is this one's for a brushless motor, which I'll talk about later, and this one is a brushed motor, which is actually the one right here, which I will talk about also later. This is the brushless motor. As you can see, they both have, let me see, this one has 3 wires from it, but this one, well, it doesn't have any specific wires, but it has 2 little electrical points in which it's connected to. All right, and then this is our transmitter. Usually it has a tail or an antenna, something for it to be allowed to transmit, or I'm sorry, receive from a controller, or also known as the transmitter. This right here is actually a switch. It's a screw switch. Right here is a little, if I can, yeah, so right here is a little, so you screw it using an Allen wrench, and based off that, it either creates a connection within the circuit or a disconnection within the circuit. And it's actually pretty good. This one right here can handle quite a few amps. However, though, there's nicer switches that you can get elsewhere if you really want to. Alright, so this is what the circuit should more or less look like. I do kind of leave out some details. Also, something I should have mentioned earlier is you can also connect your ESCs to a Arduino or a flight controller if you're using if you're going to do a drone project. Essentially, those are maybe a little bit more complex. And I should say, for an Arduino, it's more complex, but for a flight controller, it's super easy. It's just a little bit more money. And if you just want to, I don't know, you're making a BattleBot, this is perfect. This is actually a perfect little circuit for just a simple BattleBot design for you to accomplish. So right up here, as you can see, we're using the battery, LiPos, and then it's in series with the switch. Essentially, it has to be in connection with one of the wires. It doesn't have to be in connection with both the wires. That would be actually really bad. Just like what you saw with the battery, it was only connected to the other red wire, as seen previously. So moving on down the circuit, we have the ESCs, which are each connected. So the red wire is going to be connected to each of the other red wires for the ESCs, and the other black wire coming from the LiPo battery is also going to be connected to each of the other ESC's black wires. This will be important because essentially what you're doing is you're creating them in parallel which means that each ESC is going to be powered by the voltage of the battery. And the battery, let's say, is 12 volts, so each of the ESCs is going to be powered by 12 volts. That's actually pretty important to make sure that your circuit is powering everything with the correct corresponding voltage. Now I'm going to get into what the ESCs are each connected to, and I'll also show you specifically the wires of like just kind of a physically show you how they're each connected later. However, to the left was that little motor, which is the brushed. As you can see, there's two wires from the ESC with the two wires, which is connected to the brush motor. Now, I also wrote down some things which I'll get to in a second about some pros about maybe when you're selecting a motor, just to make sure that you have the right one for the right job. But always, brushed motors will have two wires. If you have an ESC with two wires, that means you have a brushed motor ESC specifically. If you have an ESC with three wires, however, that means you have a brushless motor, and it's specifically a brushless motor ESC. The differences between the two is actually both of them have their disadvantages and advantages. For just simple RC stuff, essentially a brushed motor actually has a torque when it's powered off. And this can be extremely useful. And when I mean powered off, I also mean in low voltage. This can be actually useful in many different applications. I'll let you decide, but I would say if you're doing a wheeled battle bot or a RC car, brushed is actually a good idea because it will have torque when it's on an incline. It'll be like it has brakes, essentially. They're also, when I say simple, they're super simple to design and a lot easier to just wire up in general. Instead of three wires, you know exactly what wire is connecting to which one. And you know what's the positive end of the motor and what's the negative end of the motor. Technically, if you do switch the wires, that's okay as well. And I'll also talk about brushless motors and wire switching in a second. But when you switch the two wires, it just reverses the direction of the motor, is really what it does. So for brushless motors, it's not simple to design. If they are now, brushless motors are actually more power efficient, but they're not simple to design. However, though, they're extremely fast. They're great for drones. In fact, I wouldn't even have a brushed motor for a drone because they're not nearly as fast or designed to be nearly as fast as a brushless motor. Another thing is brushless motors do not have an initial torque when rotating. However, though, so let's say you wanted to have like a blade on your battle bot. What you would do is you would actually have a brushless motor because it's really good for that, or I shouldn't even just say blade, anything spinning. If you have it rotating at a really fast speed, you would use a brushless motor, and what you'd do is you'd use this motor to charge up an attack and then hit your opponent. But if it's already hitting your opponent, as in like it's stuck, it's going to resist rotating. It's not going to continue rotating. If you want to switch the direction of a brushless motor, however, you see three wires. What does that mean? Well, that actually means that if you switch any of the two wires, that actually means that it switches the direction of the motor, just like the brushed motor. So it's actually not nearly as complicated as you think. Now we're going to go on to the receiver. So each ESC, and I drew this for simplicity, is each ESC is going to have three wires coming from it that are connected, that are meant to go to a receiver, or if you're using drones or something more complicated, it would be going to a Arduino or whatever. But for the simplicity of just a simple moving thing, you're going to, or contraption, you're going to have these 3 wires, and I would put it with the receiver. I'm going to show you what that means in a second and how to do that. It may not be obvious how to put the wires in the receiver and what order, and I'll show you guys that in a second. Just for a little bit more context for the ESC, if you hadn't read it yet, but ESCs are just motor drivers. They handle the direction of the motor, but they also handle the speed of it. That's what mainly, that's a purpose of motor drivers and ESCs in general. All right, so let's get into the wiring now. So I did show you a diagram of what was going on here, but I think it would be a good idea to show you guys physically what you guys are going to be soldering to, because mainly it's just a lot easier to maybe see for those who are visual learners. So let's go first with this brushless motor. As you can tell, it has 3 wires, and as I was saying earlier. So essentially what you're going to do is you're going to take any 3 of these wires and just connect it up. So for instance, this wire is going to go with that one, and then the next one's going to go with this one, and then the next one's going to go here. Now, obviously that may seem very basic and not so obvious. This is the ESC for the for the just brush motor. Again, what you're going to see is on this brush motor. So right here where I'm pointing is actually a little plus sign. It may be hard to see in this image, but trust me, it's there. That indicates that this wire, oh, you can see it better here. That indicates here that this terminal is actually is meant to be for the red wire, the positive current. And then this wire here is supposed to be for the negative current. Now, it technically doesn't matter which one you choose. I would just keep things consistent. And for your RC whatever, and whichever one you end up choosing, for the first one, you should do for the rest, because that determines the direction of your whatever. However, though, what you should not change the direction of is the wires for the ESCs. All right, that is a big no. These are supposed to have a certain direction associated with them. This is supposed to be the positive end. This is supposed to be the negative end. And there's no, if you switch them, it will break this ESC. All right. Now, this is what I was talking about earlier. I'm going to talk about the transmitter really quickly and how to connect this. So this is the wire I was talking about earlier. So they're always going to show 3 strands. They're going to be different colors, but usually the black one, I should say, there's always a black one that is associated with the ground. Literally these wires are going to be, this black wire here is connected to this black wire in some relationship. The middle wire is always the positive end. Now, if you have a question associated with, well, what's the voltage between the black wire and the red wire, for this is actually different from the voltage associated here with these 2 wires. These 2 wires should have the voltage of the battery, which is for this specific ESC, it needs 12 volts. However, this wire here is actually 5 volts. So if you plan on doing anything weird with it, that's just for just kind of what you need to know. The white wire here is a signal. It's actually what is called it's going to receive a PWM pulse, which is short for pulse width modulation. It's essentially it's what determines the speed of the ESC right here. Now, this circuit here is because of those 3 things. this and how this is going to be connected in this diagram over here, it's it's not going to change direction if you're using, if it's going directly to this receiver. The receiver is not going to receive a direction. That is what a flight controller or a Arduino is for, essentially. That's what would change the direction of the ESC over here, or the direction of the current going into this motor that changes the direction of the motor. This would only affect the speed of the motor. All right, so now let me just get into wiring. It's super simple. What you do is you always have the white part on top and the black part on the bottom. And then what you do is, oops, let me get a better grasp of it. You put it in like that. And then you put it in like this. You have to make sure that, again, that the white part is right on the top. The black part is always on the bottom. All right. And then what you do is you have more of these. You pretty much daisy chain them, or when I mean daisy chain, I mean you get the next ESC and you start over. You put it in the same spot, if I can, or the next spot over. Let me just fudge with this. There you go. So you may notice that each of these have a channel associated with them. Each channel is associated with each joystick in its direction. So up and down for two of the joysticks would be for channel 1 and 2, something like that. And then for channel 3 and 4, it would be left and right for the same two joysticks. That's just how they're wired. You may have to, when you're testing, may have to change which of these is which. If I remember when I did this last, I had channel 1 be, I think channel 1 and 2 and 3 and 4 are two separate joysticks, as in 1 and 2 is its own joystick, and 3 and 4 is the other joystick. So what I do is, if you're having drive motors, what you do is channel 3 and 4, and then if you have a I don't know, another contraption part or something, you do channel 1. And that's basically it for the wiring. I'm going to just show you a really quick, a complete what this should look like example. Okay, let me move everything over. So when you're complete, you should have something like this. And I actually didn't connect these to the receiver, but trust me, these wires should be connected to the receiver as shown. Now these are each DC motors, so they each have a DC motor ESC. The other thing you may see back here is, this is what I was talking about, where each red wire is connected to all the ESC red wires. The other thing to notice is that this, so, okay, well, this entire circuit doesn't have a switch. If you're doing BattleBots, you definitely need to have a switch. It's part of the rules. But it also has a plug. And the plug is very unique for every LiPo battery, depending on the size. Each of these wires is going to have a certain plug associated with the battery. You guys probably should find the correct plug. If you do, if you don't really care, I guess, and you have the right charger that doesn't require this to be connected and this to be connected into the charger, then simultaneously, then it's not a problem. For my own charger, I only need to plug this thing in and it starts charging. So technically speaking, you could cut the wires here and just connect them straight from power to ground to that. It's totally up to you guys. There are some don'ts I'm going to talk about next when you actually do physically put your circuit together. So let's get to that. Okay, so finally, here are our don'ts. So this is mainly from my experiences, like, please don't do this. This is like really like bad and may actually cause some like insane problems with your entire circuit. So the first one is exposed wire. Here's some, if you have anything like, let me find the example. So this battery right here, it has some exposed wire here. I would say don't ever do that. Like, if this is grounded at all, this could seriously damage just anything. Um, some things to avoid this would be adding heat shrink tube. If you don't know how to use it, don't worry. It is pretty straightforward. You can just ask someone. But the easiest is actually just electrical tape. It's literally just tape, and it just makes sure that the exposed wire is insulated. So the next one is hot gluing wires together, and I would pretty much just only use solder. This is arguably really close to failure. I would not, uh, I would not glue this, hot glue this. Here, moving on to the next thing. All right, so the next thing I want to talk about is when let's say you are going to be cutting any wires of the battery, all right? If you're going to be doing that, make sure to not cut them both simultaneously. I try to show a diagram here of some scissors and red wire and black wire, but what essentially happens is when you cut them both simultaneously, the current is going to go from the red wire to the black wire. So it's going to make a short circuit and is going to essentially have the battery connected to itself. The last thing I want to talk about is when you're altering a circuit, you shouldn't have the battery powered on. What you should have is like this right here, you should have it pretty much just taken out of the connector, or just have it so that the switch right here is basically is not creating is not allowing current to go through it. Anyways, that's it for this RC circuits tutorial. I hope you guys pretty much got the basics of what you need to do. It's pretty straightforward, and it's all the things you need to do. All right. I will bid you good luck with your RC projects.